So, hello everyone again. This is lecture 1 part 2 of communication systems. I am Sameer Lavankar. Let us begin. So, in the last lecture we were understanding what are the elements of a communication system, what is a transmitter, what is a channel, what is a receiver, just the basic crux of what are those equipments or what are those elements is being talked about. We may start with basic terminologies used in electronic communication system today, and hence we will move on towards the end of these lectures. For now, let me just a quick recap for you, because everything was being everything was done very quickly here. So, there is a transmitter, there is a channel, there is a receiver. So, what is a channel here? Channel can be wire in the form of wires, channel can be in the form of wires or cables connecting the transmitter and the receiver, or it may be wireless. So, for example, let us say we use a cup, we connect the cup using a wire, there is a cup again. Let us say one person's mouth is being kept here and one person's ears are being kept here. If you will speak something, then you are the information source. The message is a voice signal for you. When the voice signal is being what we can say is being captured by this transmitter, and then using these wires, this wire is nothing but a channel, these wires are nothing but a channel, and finally this piece of cup is a receiver. It goes to your ears, ears is also a receiver only, and then that passage of information is being used into some of the applications. So, this is one of the typical example, a very easy example just to explain to you what is a transmitter, what is a channel, what is a receiver. Let us move on to further slides. So, just iterating it again, then the purpose of the transmitter is to convert the message signal produced by the source of information into a form suitable for transmission through the channel. If the output of the information is non-electric signal. So, what are the examples of non-electric signal? It is a voice signal. A transducer converts into electrical form. What is a transducer? We will understand it in subsequent slides. It to electrical form before giving it as an input to the transmitter. So, let us move on to next slide now. So, when a transmitted signal propagates along the channel, when a transmitted signal, so this is a transmitted signal, it will propagate along a channel. Let us say this is the channel, this is the wire here for you, because wires are visible, that is why I am using the example of a wire. For in present day scenarios, majority of the concepts or majority of the channels are wireless only. So, when a transmitted signal propagates along the channel, it may get distorted due to channel imperfections. Anything in the real life is not 100% efficient. So, channel imperfections can be anything because of a random noise, because for example, in your radios also, when the information comes to you, you will get a jijik sound, and then you have to rotate the antennas or you have to change the frequency so that you can get clear sounds. So, that all sounds which get appear, these are nothing but noises. Because of these noises or because of this imperfect, why are these noises coming? This is because the method or the channel we are using is not completely perfect, it is not 100% ideal. Let us say this is the wire and this wire has some leakages here, leakages as in the wire is, let us say, of width 2 mm or let us say 2 mm, and now at some point or some location it is being torn like this, let us say it has some bulginess somewhere. So, these are nothing but channel imperfections only. So, due to these channel imperfections, the transmitted signal gets distorted as in disturbed, or let us say there is a piece of information, the piece of information gets in pieces, or let us say a part of information is being reduced to 0 only, the sound of that part gets reduced to 0 only because of these distortions. Why these distortions happen? Due to channel imperfections. So, I tried to explain to you basically what is channel imperfection. So, like a breakage is here, or some wires are being torn like this, or let us say the width is increased in some places. So, these can be channel imperfections. Next is moreover noise adds to the transmitted signal. So, noise adds to the transmitted signal and the receiver receives a corrupted version of transmitted signal. So, as I explained to you using the application of FMs. So, the sounds which comes are nothing but noises only, which are so the transmitter is a person, he speaks, the FM jockey speaks something, but he does not speak the noises. These noises are being added or these are being corrupted when you receive the signals, when you receive the noises. So, moreover noise adds to the transmitted signal and the receiver receives a corrupted version, corrupted as in not completely ideal to the version which was being sent by the user, sent by the information source, receives a corrupted version of the transmitted signal. The receiver has the task of operating on the received signal. So, now receiver has to work with only that piece of information, that bit of information which was being received by it. It can be distorted, it can be partially distorted, it can be completely distorted. So, now everything has to be worked using that bit of information only. So, the receiver has the task of operating on the received signal. It reconstructs a recognizable form of the original message signal for delivering it to the user of information. So, as you already knew from the last slides that what does a transmitter do? It converts those, let us say this is a voice signal. So, voice signal was being converted using a transducer to electrical signal. But let us say I am a person here, the receiver is also a person here. What can a receiver understand from an electrical signal? It will only understand the passage of information I am speaking by my words, it can understand my English language only. So, electrical signal has to be converted or reconstructed again to voice signals, then only you can understand whatever I am saying. So, the concept or the devices required for this conversion or this back analysis or this back reconstruction is nothing but the use of or the application of receiver. So, receiver reconstructs a recognizable form of the original message signal for delivering it to the user of information. Next, there are two basic modes of communication, point to point and broadcast. So, again an information for you only, but if you look clearly you can understand from the line only. So, point to point as in let us say this is a point, this is a point, you have to pass the information from one point to another point. What does a broadcast mean? Broadcast means now there is not point to point. So, let us say there is one single source and it has been broadcasted to many user of information. So, let me iterate to you whatever is written on the left. So, there are two basic modes of communication, point to point and broadcast. In point to point communication mode, communication takes place over a link, let us say this is a link between a single transmitter and a receiver. So, there is a single transmitter, let me denote it by single transmitter, and there is a single receiver, So, telephony is an example of such a mode of communication. So, it is quite evident, let us say you call a person using a mobile phone. So, you are directly in call with the other person receives your call and then you communicate your information, you pass your information. So, let us say this is single transmitter and this is single receiver. So, there is single. So, that is why telephony or telephone equipment is nothing but a point to point communication mode. Next is so telephony is an example of such a mode of communication. In contrast, so now what is a broadcast? In the broadcast mode there are a large number of receivers. So, large number of receivers as in, if I make you a diagram for it. So, large number of receivers, many links are there. There are large number of receivers corresponding to a single transmitter. So, transmitter is single now, single transmitter. Radio and television are examples of broadcast mode of communication, quite evident. Let us say there is a journalist, let us say there is a news channel. So, in the news channel there is a single transmitter and a video camera is there, video camera captures the journalist and then everyone in the complete country receives those signals using antennas and satellites, and then it is broadcasted to you. So, only a single person, only a single journalist gets viewed up in every of the televisions in all over the country. So, this is an example of a broadcast mode of communication. So, this point is also being iterated to you. So, let us move on to next slide. So, now we will go with what are the basic terminology, some of the important concepts used in communication systems, so that we can get to know the future things like what is a bandwidth, what is a signal, what are the different types of waves, what is modulation, as I already told you in the introduction chapter. So, let us move on to the basic terminologies used in electronic communication systems. So, following are the basic terminologies used in electronic communication systems. The first is a transducer. Please iterate back in some 2-3 slides back. So, I told you what is the use of transducer in a single line. Let me iterate to you again. It was being used in a transmitter. So, where it is? Yes. So, what is a transducer? A transducer converts it. What was it here? It was a non-electric signal. So, let me write it here again only. So, it was a non-electric signal. So, a transducer converts it. What is it here? It is a non-electric signal to electrical form before giving it as an input to the transmitter. So, just before transmitter, let us say this is the portion here, just before transmitter there is a transducer involved, and it converts any non-electric signal like voice signal to electrical signal. So, this is the work of transducer. So, any device that converts one form of energy into another can be termed as a transducer. In electronic communication systems, we usually come across devices that have either their inputs or outputs in the electrical form. So, one of the subsection or subclass of transducer used in transmitter device in the previous slides was that the output is a electrical signal and the input was a non-electric signal. Either way is also possible. If let us say there is an input which we need as a electrical signal and the output is being required as a non-electric signal, then that device which converts the input into output is also called as a transducer. Moreover, making a more subclass of this transducer, any device that converts one form of energy into another form is known as a transducer. Next, an electrical transducer may be defined as a device that converts some physical variable. What is a physical variable? It can be either pressure, displacement, force, temperature, etc. into corresponding variation in the electrical signal as its output. So, every time it is not that only voice signal will come. Sometimes people use pressure devices. So, passage of information is not only related to your passage of information. Sometimes let us say I am also speaking, this is nothing but a immaculation of waves. So, those waves create some pressures or create some force. Those pressures or those forces have some value, let us say they have a magnitude. Those magnitudes are being captured by those transducer and then it converts, it has a proper calibration for every of the voice signal I am using. Every voice signal which is coming out of my mouth has a pressure induced to it, has a force induced to it. So, then these forces and these pressures are being calibrated in the transducer and it converts each word or each form of wave coming out of my mouth into an electrical signal. So, it can be either pressure, it can be either displacement, it can be either force, it can be either temperature. So, what it does is it converts or this changes this some physical variable into corresponding variations in the electrical signal as its output. The output is nothing but here electrical signal. On the right hand side, these are some of the typical transducers which we found in our real life. So, there is an RTD, there is thermocouple. Thermocouples are being used when the input variable is related to temperature. Thermo is, as you can already, it is quite evident, thermo is related to heat. Potentiometer is there. I will not go into details of this, just for quick reference or just to know what is a transducer, how does it look like, I explained to you with this picture. So, there is an RTD, there is a thermocouple, there is a potentiometer, there is a piezoelectric crystal, the strain gauges are nothing but it has an input variable of displacement, So, it is used to calculate strain. Strain is nothing but it is a physical concept. let us say there is a bar of length L, and when you compress it, let us say there is a displacement or there is a change in the size or dimension of this bar by delta L. So, strain is nothing but delta L upon small l, this is known as strain. So, what does the strain gauge do? It calculates the value of strain and gives to you, and an LVDT. Just to know the example, I will not go into details of these things. So, next basic terminology is signal. What is a signal? So, signal. Next is signal. What is a signal? So, signal is the information converted in electrical form and suitable for transmission is called as a signal. So, anything let me use the communication system figure here. So, let us say you are at this position, you had a non-electric signal here. So, let us say this was the portion where I install a transducer. So, let us say this was the portion where I install a transducer. So, what does it do? Before transducer there was a non-electric signal, let me write non-electric signal as NES for now, and after transducer there is an electric signal. So, now you have an electrical signal, let us move on to electric signal part. So, now information converted in electrical form. So, now you have the information converted into electrical signal, information converted into electrical form, and it is suitable for transmission, because transmitter can now receive, it can forms that come to me, information can be bypassed through me, because now it is in the form of electrical waves. So, information converted in electrical form and suitable for transmission is called as a signal. So, this is a basic information, basic definition of a signal. Signals can be either analog or digital. So, maybe this may be a new line for you, but when I will explain to you what are the applications or what are the examples of analog and digital, you will get to, maybe you will know that these are nothing but basic day to day things which we use in our real life. For now, I will end the lecture here only. So, just again iterating, what is a signal? Information converted in electrical form and suitable for transmission is called as a signal, and signals can be either analog or digital. What is an analog signal, what is a digital signal, we will get to know in the next lecture. For now, let us end this lecture. Thank you.